Today we're going to talk about the network. The network, it is basically a group of computers that accept the consensus rules, and that they are agreeing to follow all the rules. Uh, that's what they are agreeing to. So they are agreeing to conduct themselves in an honest way by following the longest chain. As we reviewed before with proof of work, proof of work is based on the concepts of choosing the longest chain, which is considered the most honest chain. Um, so, and I just love it. I love it. So, here the network. The steps to run the network are as follows. Number one, new transactions are broadcast to all nodes. As explained many times before, all transactions are being propagated to all nodes. So there's no a single point of failure here. The second one is each node collects new transactions into a block, right? They're being accepted, every transaction is being accepted into a block by a process called proof of work, and they have to mine it to include it into the block, respecting all the rules. And of course, the rule of the longest chain also applies. So number three, each node works on finding each node works on finding a difficult proof of work for its block. With the leading zeros that we talked about in proof of work, the leading zeros in the hash, that's what indicates how hard it is um, to mine that block. The difficulty adjusts itself every 10 minutes. We didn't discuss that in the previous section, but the difficulty target, those leading zeros, adjust themselves depending on how hard it is and how many miners are present in the network. That's as simple as that. Actually, depending on how hard it was before, like the 10 minutes before, if it was that easy, if it was too easy to mine, then it becomes a little harder. It adjusts itself based on the number of a different number of parameters. So each node works on finding a difficult proof of work for its block, right? So when a node finds a proof of work, it broadcasts the block to all nodes. Then the nodes accept the block only if all transactions in it are valid and not already spent. Right? They're trying to get rid of the double spending that we talked about before. No more double spending. If everyone spends the coins that they have one time, as long as they have it, and everybody knows that from your address you have the exact coins that you claim you have, that's the only thing that really matters here for double spending. Everyone verifies everything. That's pretty much what it boils down to on step 5. So all the nodes are broadcast, and only the transactions that are valid are accepted. There's certain criterias, but we don't need to get into this right now. And also, no more double spending. Step 6, nodes express their acceptance of the block by working on creating the next block in the chain using the hash of the accepted block as the previous hash. So remember, every block has a hash, that contains the list of all the transactions linked together in order of acceptance in the block. It's not as easy to accept a transaction in the block. And remember, you need to go through the proof of work mechanism to accept one single transaction into a block. So just imagine, we'll at some point go over what the transaction looks like. Like, hey, let's say Alice wants to send some money to Bob. How does that really work? I'm more than happy to dive into that. It's actually super fun. But essentially, there's some work called proof of work that we talked about in a previous video that goes into it. So that's what they do. That's what's happening on basically every block full of transactions have a hash number that is linked to the previous hash of the previous block, right? And every node has to accept that this is how it works. So every node verifies it every single time in every block, in every transaction. So that's the last step. And it pretty much encompasses everything we've spoke about. And that's what makes the network, because every node does the same thing. There's no node that will do anything different. And that's what makes it honest. This is what the honest chain will do. Anything different from that is not honest. It's dishonest, and they're trying to manipulate anything. And the majority will never accept it. That's what I love the most about this entire, at least these 5 chapters, at least these first 5 chapters are pretty much linking to one another. And here, as we're talking about the network, we're talking about every node, every computer, your computer, if you decide to take part of this, into this. So every transaction or broadcast, each node collects the new transaction to a block. Each node works on finding a difficult proof of work for its block. When a node finds a proof of work, it broadcasts the block to all nodes. So we're all working together to broadcast all the good nodes. All the good blocks, all the honest blocks, to create an honest chain that will be the blockchain. The blockchain is full of honest nodes, and anything diverting from that is not honest. It's pretty simple. We look for honesty, and nodes we only accept the block only if all transactions in it are valid and not already spent. Simple. The nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. So everything is linked together to create the blockchain of honest previous hash of the previous block, and that creates the honest chain, the honest blockchain. So let's kind of finish reading here. Nodes always consider the longest chain to be the correct one, and will keep working on extending it. If 2 nodes broadcast different versions of the next block simultaneously, that's what creates a fork. But we'll talk about it a little more later. Some nodes may receive one or the other first, right? So if 2 nodes broadcast different versions of the next block simultaneously at the same time, what happens is that some nodes may receive one version of the block, and others will receive the other first. So in that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie, so it's like a fight, right? A fight of which one is the truth if they receive 2 blocks at the same time. The tie will be broken when the next proof of work is found and one branch becomes longer. Remember, so the longest chain is the truth. The nodes that were working on the other branch will then switch to the longer one. So, it's pretty interesting, because a lot of people will be confused. What happens if 2 blocks are mined at the same time? What happens? That's possible. It's pretty rare, but it's possible. And if it happens, then again, the longest chain is what will determine the outcome. Like, the truth will prevail with the longest chain, and everybody will merge to the longest chain. So new transaction broadcasts do not necessarily need to reach all nodes. As long as they reach many nodes, they will get into a block before long. Block broadcasts are also tolerant of dropped messages. If a node does not receive a block, it will request it when it receives the next block and realize it missed one. So essentially, um, all the transactions are going to be broadcast, and that's pretty much all that really matters, right? For you and I, when we make a transaction, all we care about is that the transactions go through properly. If you include the right amount of fee, those transactions will go through based on these network rules, these network algorithm, the proof of work algorithm that is being implemented by the miners, and all the nodes accepting all those rules, like those 6 rules that we just read. Those are the rules of the consensus. That's what we all agree on when we are making these transactions. This whole network is designed to be self-sufficient uh, when it comes to propagating transactions. The last sentence was pretty much explaining that, not all nodes need to be reached because not all nodes need to be trusted. It's very simple. It's all about that trust level of making sure that we only care about the honest nodes, which is the longest chain. So some nodes may have or may want to be working with a different algorithm. For example, that there will, maybe they only want to propagate to their node or something just off, right? They just want the transactions to be propagated through a different group of nodes that is following a different set of rules, right? Uh, if the majority doesn't agree, that is not an honest block. That is not an honest transaction or um, uh, proof of work algorithm being followed. So that's pretty much all this network section is encompassing. Next, we'll talk about incentives, but it's actually really interesting to talk about incentive. But this is just to summarize what the network section is talking about in these 9 pages. So I hope that this network section has been informative. The whole network needs to work as a consensus together to enforce rules. Otherwise, that wouldn't work. So this network, it's actually super important. To kind of finish up on this point, if there were only 1 or 2 computers, that wouldn't create a network. We would have to rely on those 2 computers or that 1 computer to validate all the transactions. And that wouldn't be doable because those 2 computers or that computer will be shut down immediately. And that's when we come back to the current system that we have that is called a centralized system because it has a single point of failure where if something's wrong, we spoke about this before, but we pretty much enjoy having to knock at somebody's door and demand for our funds back. In Bitcoin, everything relies on the network and there's no doors to knock at. So everybody's pretty much responsible for everything at the same time because we kind of all vested in it, essentially. So this is gonna close this whole section, and I hope that this has been informative for you. And I will talk to you in the next one. Thank you. Bye bye.